We're counting down the 8 most groundbreaking transportation systems now operating in China, each one breaking records and global expectations. From vessels that skim just above the sea to futuristic vehicles gliding silently at 1,000 kilometers per hour, these technologies promise everything from 40% fuel savings to level 4 autonomy and speeds once thought impossible. Which invention is set to redefine the limits of human travel? Let's begin the journey with number 8. Just above the ocean's surface, the Airfish 8 glides at speeds up to 185 kilometers per hour, powered by twin V8 engines and shaped to ride a cushion of air. Unlike a plane, it never climbs higher than 7 meters, staying in the sweet spot where ground effect physics boost lift and slash drag. This unique design means the Airfish 8 can travel between islands or along coastlines, using up to 40% less fuel than a traditional aircraft on the same route. Its carbon fiber body and shallow draft let it operate without runways, opening up remote areas that ferries or planes struggle to reach. Certified under maritime rules, the Airfish 8 is built to handle calm seas and moderate waves, making it a promising choice for short-haul, fuel-efficient island hopping. Electric hydrofoils transform coastal travel by lifting their hulls clear of the water, gliding above the waves on slender underwater wings. This design slashes drag by nearly 80%, allowing battery-powered ferries to move at commuter speeds while using a fraction of the energy of traditional boats. On popular routes between city harbors and island towns, these zero-emission vessels carry dozens of passengers in near silence, leaving only a thin wake behind. The hydrofoil's lift-to-drag advantage means less strain on electric motors and longer range per charge, even in choppy sea conditions. Unlike conventional ferries, which push through water and burn fuel, hydrofoils rise up, reducing contact and letting clean propulsion do the work. Operators monitor sea state limits, typically up to 1-meter waves, to keep rides smooth and safe. As more cities adopt these ferries, they offer a glimpse of coastal transit, where efficiency and sustainability travel together, setting a new standard for green marine mobility. Above the city skyline, the EHang 216 hovers into view, a passenger drone powered by 16 independent rotors, each one a fail-safe against mechanical failure. This electric aerial taxi is designed to make urban commutes almost unrecognizable. A journey that once meant an hour stuck in gridlock now takes just 10 minutes by air. The EHang 216's battery pack supports flights of up to 35 kilometers on a single charge, enough to link city centers with distant business districts or to ferry travelers across rivers and congested highways. Its autonomous flight system, guided by onboard sensors and real-time data, eliminates the need for a pilot. The Civil Aviation Administration of China has granted limited approvals for commercial demonstration flights. Early trials have logged dozens of successful routes, with safety records bolstered by the drone's multi-rotor redundancy. For city dwellers, the EHang 216 offers a glimpse of a future where vertical mobility is not a luxury, but a practical answer to the daily squeeze of urban life. Urban congestion in China's megacities has inspired some of the world's most radical transit experiments. The straddling bus concept, first unveiled as a full-scale prototype in 2016, aimed to solve gridlock by carrying up to 300 passengers in an elevated carriage that glided above existing traffic lanes. With a structural clearance of 4.8 meters, the bus allowed cars under 2 meters tall to pass underneath, promising to turn rush hour into a smooth ride for both commuters and drivers below. The prototype's electric hub motors and modular design hinted at a future where dozens of these vehicles could be linked together, flexing around corners and loading passengers from raised platforms. Initial tests on a 300-meter track in Qinhuangdao generated global headlines and hopes for a new era of high-capacity, low-footprint public transport. Yet, despite the bold vision and massive media attention, the project stalled amid technical doubts and financial controversy, leaving behind a tantalizing glimpse of what urban mobility could look like if engineering and ambition can align. A new kind of city train glides through the streets of Zhuzhou, but there are no rails beneath its wheels. This is the ART, the Autonomous Rail Transit System, a battery-powered vehicle that follows optical lines painted directly onto the asphalt. Instead of digging tunnels or laying steel tracks, engineers use a mix of LiDAR, GPS, and sensor fusion to guide each multi-car unit with metro-like precision. The ART can snake around corners, split into shorter trains, or link up for rush hour, all while moving passengers with the capacity of a light metro. Construction costs drop to just 20% of a traditional subway, making high-frequency service possible even for smaller cities. Early deployments in Hunan and Jiangsu provinces have shown that these railless trains can be up and running in months, not years. By relying on software and sensors rather than concrete and steel, ART offers a rapid, scalable solution for urban transit that sidesteps the cost and disruption of old-school infrastructure. Baidu's Apollo Robobus operates on city streets with no steering wheel, no pedals, and no driver's seat, just a bank of sensors and a wall of screens where a dashboard used to be. This Level 4 autonomous fleet has logged more than 10 million kilometers in real-world traffic, collecting data from day and night runs, rainstorms, construction zones, and the unpredictable chaos of urban life. Each vehicle uses a combination of LiDAR, radar, and high-definition cameras to read its environment, while vehicle-to-infrastructure communication lets it anticipate light changes and reroute around accidents in real time. Permits granted by city governments in places like Chongqing, Wuhan, and Guangzhou have opened busy public routes to these robobuses, allowing them to operate alongside human-driven cars and traditional buses. Safety drivers remain on board for regulatory compliance, but the system's software handles all driving functions, recording disengagement rates that rival or surpass those of Western rivals. The sheer volume of logged kilometers gives Baidu's engineers a data advantage. Every stop, turn, and close call feeds back into an artificial intelligence system that learns and adapts faster with every trip. As the fleet expands, each new vehicle joins a growing neural network, making the entire system smarter and more reliable. This scale of autonomous transit is not just a technical showcase, it is a working model for how artificial intelligence-driven public transport can operate safely at city scale, setting a precedent that competitors around the world are now racing to match. On the outskirts of Datong, Shanxi Province, a sealed steel tube stretches for 2 kilometers across the landscape. Inside, a magnetic levitation capsule has already reached 623 kilometers per hour, setting a new record for ground transport in China. This is the T-Flight Hyperloop, a project developed by the China Aerospace Science and Industry Corporation. Engineers maintain the tube's internal pressure at a fraction of normal atmospheric levels, reducing air resistance to almost nothing. Within this near vacuum, the capsule floats above the guideway, held steady by electromagnetic forces with less than 0.3 millimeters of track unevenness. The result is a ride so smooth that passengers describe it as absolute tranquility. No vibration, no engine noise, only the faint rush of displaced air as the pod accelerates. Plans are underway to extend the test line to 60 kilometers and push speeds toward the 1,000 kilometers per hour mark. Achieving this means overcoming the relentless challenge of maintaining a perfect vacuum over long distances, managing thermal expansion in kilometers of steel tube, and keeping levitation systems stable as speeds climb. If successful, T-Flight could make city-to-city travel as fast and effortless as stepping into an elevator, setting a new benchmark for ground transportation just below the threshold of hypersonic flight. At the edge of aerospace possibility, a new contender is taking shape in Chinese laboratories and desert test sites. In October 2024, the Yongxing prototype from Lingang Tianxing Technology completed its maiden flight, pushing the boundaries of what is possible for passenger jets. Powered by a rotating detonation engine architecture, sometimes called mutter or Jindu, the aircraft blends turbofan, rocket, and ramjet power in one frame. This hybrid engine design allows for acceleration past Mach 6, a speed that would cut the Beijing to New York journey from over 12 hours to just 2 hours, a truly hypersonic leap. During a classified 2021 test over the Gobi Desert, a research team from the Chinese Academy of Sciences reported a sustained Mach 6.5 run that lasted 20 minutes, the fastest known flight of its kind. The engineering challenge is not just raw speed. At these velocities, skin temperatures soar past 1,000 degrees Celsius. Project teams have developed ceramic cooling systems and heat-resistant alloys to keep critical components from melting in flight, drawing on breakthroughs in high-temperature materials science. Unlike the Concorde, which topped out at Mach 2 and faded from service in 2003, China's prototypes are built for both speed and scalability. The Nanqiang No. 1, slated for a full-scale passenger version by 2035, is designed to seat 10 and uses a fat, round fuselage with broad, cape-shaped wings to manage lift at hypersonic speeds. As US startups and NASA race to revive supersonic travel, China's approach stands apart for its ambition and its ability to move from concept to operational prototype in less than a decade. The hypersonic leap is not just a technical feat, it is a statement of engineering dominance, rewriting the rules of long-distance flight and sending shockwaves through the global aerospace industry. Across all 8 breakthroughs, one pattern is clear. China's transportation revolution isn't about single inventions. It is relentless, scaled innovation. These aren't isolated prototypes. They are operational systems rewriting global standards. The future of movement is already taking shape, and the world can't afford to look away. What surprised you most?